Hello class. Today we're continuing our practice of algebra before we get into our AP Calc curriculum. And today we're going to be talking about factoring. In specific, three types of factoring. The first one is the product sum method. The second one is the A times C method. And the third one is the difference of squares method. Now, the difference of squares we're going to talk about at the end. It's a very specific kind of factoring that we'll only be doing in specific cases. But first, let's talk about the general form of a polynomial that we will be factoring, in particular using the product sum in the AC method. And that would look like this: ax squared plus bx plus c, where a, b, and c are numbers. So we'll actually have numbers written in there. Now, depending on what our polynomial will look like, we'll be using one of these three different methods. Now, trinomials, which this is, will be using either the product sum or the A times C method. But when do we use which one? Well, let's talk about that. To use the product sum, that's the easier of the three. We use it when A equals 1. So use product sum when A is equal to 1. And so remember, if there's a 1 in front of a variable, it's just the variable. So it would just be like x squared plus something, something, something. That's when we'll know when to use the product sum. And the steps when doing the product sum, step one is really, I guess, probably the only step, and that is find two numbers that add to B and multiply to C. So let's take a look at a few examples here. First, we'll start off with something like this: x squared plus 11x plus 10. So following our steps, we need to find two numbers that add to our b, which is 11, but multiply to 10. So this could take some kind of guessing and checking in your head, or you could write it out. So we need to find two numbers that add to 11, but multiply to 10. And those two numbers are going to be 1 and 10. 1 plus 10 is 11. 1 times 10 is 10. So what we're going to do with those two numbers, we're going to factor up our polynomial. There's going to be an x at the beginning of each factor. And it's going to be a positive 1, positive 10. You just put those right here. And they're both positive, so plus 1, plus 10. And it doesn't matter if you put the 10 first and the 1 second, that it's neither here or there. It's either one. So let's talk about another example here of the product sum method. And this one we will do x squared plus 2x minus 8. And again, we want to find two numbers that add to the 2 but multiply to negative 8. So let's think about what it takes for something to multiply to a negative, right? We need to have one positive and one negative factor. So sometimes what I like to do is off to the side I like to make a little tree. Let's see, make it in green. We'll make it in, what is this, lavender? I don't know. So I like to think of 8. And I think, okay, what are factors of 8? I start with 1. 1 times what is 8? Well, 1 times 8. Then I go to 2. Does 2 go into 8? Yes. So 2 times what? 2 times 4. And then 3 doesn't go in. 4 times 2. Okay, so these are all the factor sets of 8. Knowing that we're actually multiplying to a negative 8, one of these factors has to be negative. And which one of these factors add up to 2, given that 1 is negative? Well, a negative 1 and 8 would give us negative 1 plus 8. That would give us 7. Flip that around. 1 plus a minus 8. 1 minus 8 is negative 7, so that's not it. Then looking here, 2 and 4, this looks like to be the 1. And specifically, if we have a negative 2 and a positive 4, negative 2 plus 4, or 4 minus 2, if you will, is a positive 2. So these are our two numbers that we'll use. And again, we just write our little factors here. X's go in the beginning. And let's see, x minus 2 and x plus 4. And that's it. Let's do one more. We'll do this one in green. And say we have something like x squared minus 8x plus 12. Now, this time, we are adding to a negative 8, but we're multiplying to a positive 12. So let's think about what kind of numbers we need in order to add to a negative number. Well, in order to add to a negative number, we need at least one negative number in there, right, to get into that negative land. But we know that if we have one negative, one positive, we're multiplying to a negative, which in this case we're multiplying to a positive, so that's not true. But what happens when we multiply two negatives together? Well, if we multiply two negatives together, we still get a positive, but they add up to a negative. So in this case, we know our two numbers we're looking for are both going to be negative. So again, I'm going to create my little tree, and a lot of you could probably do this in your head. But let's see here. I know 1 goes into 12, obviously, 1 times 12. And remember, both of these numbers we're going to consider negative. And then 2 goes into 12, 2 times 6. 3 also goes in 12, 3 times 4, and then 4, well, 4 times 3, and we're done. So these are all the factors of 12. Which one of these, given that they're both negative, would add up to negative 8? And our answer is negative 2 and negative 6. So our numbers here is x minus 2 and x minus 6. And there we have it. We have it factored. Let's go on to the A times C method. Now, this method is a little challenging. I'll be honest with y'all. But as long as you follow the steps, it shouldn't be too bad. And I promise we won't be using it very often. I just really want to show you guys so that y'all have it in your little book of tricks. Because factoring can be one of the most confusing things algebraically. The product sum, we're still dealing with we're still dealing with this ax squared plus bx plus c business, where a, b, and c are all numbers. But we use the A times C method when A is greater than 1. So A being greater than 1, we're actually going to have a number out front here, right? Unlike our last example when A is 1, it's just x. But let's kind of go through one first, and then we can talk about the steps that we took to get there. And we'll write those down afterwards. So let's say that we have 2x squared plus 17x plus 21. Now, we can't use the A times C method on this because, excuse that hair, because 2 is not 1, right? It's in fact greater than 1. So our first step, and let's write the steps as we go. Our first step is we want to multiply our A times C. So multiply A times C. And when we do that, And we're just going to write it off to the side here. We're not going to put it into our equation or anything. We're just going to write it off to the side. So A times C is 42. Now, multiply A times C and find, wrote it backwards, and find two numbers now that multiply to 42 but add to 17. Now this is kind of like our product sum method, right? So find two numbers that multiply to our A times C and add to B. So these numbers tend to get a little larger because we are multiplying first, right? 2 times 21 gets us 42, which was larger than any of the numbers we worked with before. So I definitely like to do these trees here. Now, both are positive, so we know we're working with all positives here. And the trees, again, I like to start with 1 because I know that always goes into it. 1 times 42. Then I go to 2. 2 times 21. And then let's see, 3 does 3. Yes, 3 goes into it. 3 times 14. 4 doesn't, 5 doesn't, 6, yes, 6 times 7. And then 7, well, 7 times 6, and we're done. These are all the possible factors of 42. Now, which one of these adds up to 17? You already see it, 3 and 14. So our step 2 is split B into 2. Split B into 2 terms using our two numbers. So what I mean by that is I'm not going to change the nature of the polynomial. I'm just changing how it looks, or what it looks like. So I'm going to rewrite it, 2x squared, and we have 3 and 14. Now, it doesn't matter which one you put first, just like another one. I'm just going to put 3 first. So plus, because we're both positive, 3x plus 14x plus 21. You might be wondering where do these x's come from? Well, that's just from splitting this up, because we have 17 x's total, and we're just splitting it up into a set of 3 x's and to a set of 14 x's. So we didn't change the function whatsoever. And then finally, our last step is to factor by grouping. Hopefully, this looks a little familiar to us, factoring by grouping. And to factor by grouping, what we do is we split up the equation, or the expression or function, in this case an expression in the middle, and we want to factor the left side and factor the right side. So we talk about greatest common factors. So factor by grouping using greatest common factor. So I like to think, what is the greatest common factor between the numbers? In this case, it's just 1, right? And then what is the greatest common factor between x squared and x? In this case, it's x. X is the largest. So 1x is the largest number that goes into both of the, or largest factor that goes into both 2x squared and 3x. So I'm going to pull that out. And then I'm going to write what's left. And really, we're dividing this x out. So 2x squared divided by x is 2x. And then 3x divided by x is plus 3. And then over here, we're going to pull out the greatest common factor as well, just like what we did on the left side. Let's see here. We have 14x and 21. So it looks like to me the greatest common factor is just going to be 7. And the reason it's 7 is because 7 is the largest number that goes into both 14 and to 21. And they don't share an x in common, so we can't pull out an x. So it's just 7. And then, again, we're really dividing the 7 out. Whatever we pull out, we're dividing out. So 14x divided by 7 is going to be, what, just 2x? And then 21 divided by 7 is 3. And as you can see, and hopefully, if we did this right, our two factors that we created are the same. They have to be the same in order for it to do the next step. The next step is the last step. I might have said this step was the last step, but it's not. I forgot. Last step is just rearrange. We can actually rearrange this last step so that these two factors that we pulled out go into a single factor, so x plus 7. And then we have these two turn into 1, or one factor of 2x plus 3, since they're the same. And there we have it. We just factored using the A times C method. So let's go over another example of this, just to make sure that we have it. And I warned you guys that this one was probably the most challenging one. But with practice, we should be able to get it. So the next one, 8x squared plus 2x minus 3. So let's follow these steps and just factor this thing. So our first step, remember, was multiply A times C. Eight times a negative 3 is going to be negative 24. And remember what the negative means. Let's see. We're multiplying to a negative, so one of our factors must be negative, one must be positive, and we're adding to a negative, or we're adding to a positive. So, okay, so we're good. All right. Again, I like to make the factor tree. Start with 1. 1 times 24. 2 times 12. 3 times 8. 4 times 6. 5 doesn't go in. 6 goes in, but 6 times 4. We already have that one. Okay. Now, which one of these, given that one of the factors is negative, will add up to 2? So remember, they need to multiply to negative 24 and add up to this b value. And in this case, it's 4 and 6. And specifically, the 4 is going to be negative. Now, remember, we split up this middle term. And we tack on the x's at the end. So 8x squared. And it doesn't matter which one you do first. I'm going to put 4, just because I guess that's what I have first. Minus 4x plus 6x minus 3. And now that we've split it up, now we factor by grouping again. So I like to just kind of do this little dotted line. Just kind of keeps my brain in order. You don't have to do it, but helps me. So greatest common factor between 8 and 4 is 2. No, I'm sorry, it's 4, isn't it? 4 is the largest number that goes into both 8 and 4. So 4. And then the largest greatest common factor between x squared and x is just x. So 4x is the greatest factor we can pull out. And then remember, we're really dividing that 4x out. So 8x squared divided by 4x is going to be 2x. And then negative 4x divided by 4x is negative 1. And if you ever want to double check your work here, you can distribute your value, your greatest common factor back in. Like 4x times 2x is 8x squared. 4x times negative 1 is negative 4x. So if you're ever not sure, you can always do that. So now let's take the greatest common factor out of 6x and negative 3. And that will be 3. So a plus 3. And we can't take an x out because they don't both have an x in common. So 6x divided by 3 is just 2x. And negative 3 divided by 3 is negative 1. Again, you want to check that these two factors are the same. We're good. And then we just want to rearrange them. So remember, the greatest common factors that we pulled out can go into the first factor. It doesn't matter if it's the first or second one. And then the two factors that are the same go into the second one. And there you have it. Let's do one more of these examples, and if ever you feel like you've got it, you can always skip ahead and to the next part when we're going to be talking about the difference of squares. But let's do one more just so we have it in case we need it. All right, this one is going to be 2x squared. 2x 2x squared minus 9x minus 18. Okay. So again, multiply a times c. Two times negative 18 is going to be negative, what is that? 36. And now I'm going to make my little factor tree here. So 1 and 36, 2, 18, 3 and, what is that, 12, 4 and 9, 5 doesn't go in, 6 does. 6 times 6, and we're done. These are all the possible factors of 36, and specifically negative, one of these factors will have to be negative, right, to get that negative 36. So we need to find which set of these factors multiplies a negative 36 but adds to negative 9. And in this case, it looks like it's going to be 3 and 12, and 12 will have to be the negative. So these are the two numbers that we're going to use to split up this negative 9x. So we have 2x squared, and again, it doesn't matter which one you do first. I'm going to do plus 3x minus 12x minus 18. And again, I'm going to split this up. We're going to factor by grouping. Now, the greatest common factor between 2 and 3, again, is just 1. So we're going to take out a 1 technically, but I don't need to write it since we have an x. And then the greatest common factor between x squared and x is x. So I'm going to pull out an x. And we're going to divide both of these by x. So 2x squared divided by x is just 2x. And then 3x divided by x is just plus 3. And do the same thing with the right side. Now, here's something we noticed right off the bat with the right side in this particular equation, problem. Is that we both have negative, or both of these terms are negative. And remember that we want the remainder here, or this factor right here, to both be positive. So we're going to have to pull out a negative. Okay? So let's pull out a negative. And what's the greatest common factor between 12 and 18? It looks to me to be 6. So a negative 6, in fact, we can pull out. And that's going to make both of these positive. So let's see. Negative 12x divided by negative 6. Well, negative times negative is positive. 12 divided by 6 is 2. And then x is not being canceled out by anything, so 2x. And then negative 18 divided by negative 6 is positive 3. So that's a little trick. If they're both negative and these are all positive, just pull out a negative here. And then again, finally just rearrange it. So x minus 6 and 2x plus 3. Boy howdy. Yeah. So that is the a times c method. But I promise we won't be using it that much. Just make sure it's in your bag of tricks. You will have some questions on your assignment today about these, though. Okay. Now going on, finally, we're at the difference of squares method. So the difference of squares method, we want to generally, well, the difference of squares method is when we have something like this, where we have an ax, how would I put this? Ax squared minus b, something that looks like that. Well, maybe I should put it like this: ax, where everything is a square number. Okay. And so the general form of this is if we have something that looks like this, where we have an a squared x squared minus b squared, where everything is a square, it really equals, and this is nice because we have a little formula, we don't have to do all this algebra, a plus b times a minus b. And that's really it. So let's take a look at an example here. Say if I have, maybe we should say use difference of squares when I guess technically we have a difference of squares. Remember, difference is subtraction, so it's the difference of two squares here. When we have a difference of squares, I know that sounds redundant, but that's how we know when to use it. It's kind of, it's named after itself. So let's say that we have something like x squared minus 9. Well, let's see. A is what? A is 1, right? Because A is in front of the x. And then x squared just goes to x, right? So we don't really need to write that. And then b is what? B is 3. Square root. Remember, square root numbers that when multiplied by itself equals that number. So we have 3. So basically we just put it into this form. Ooh, I'm sorry, I should say I goofed. This should be ax. Ax plus b, ax minus b. That's my apologies there. So we will have, let's see. Oop, my mind just exploded. Okay. Not in a good way necessarily. So now we have a is just 1, so we don't need to write it. X plus 3 times x minus 3. Something like that. That's it. Let's just go over another example of it. Say we have 16x squared minus 25. Well, a is just going to be 4, right? The square root of 16 is 4, and the square root of 25 is 5. So it's really just going to be 4x plus 5 and 4x minus 5. And that's really all there is to it for the difference of squares method. So get started on the worksheet. Let me know if you have any questions. I will be here, and of course, have fun. Thank you.